apologise for being late, but my excuse is that it wasn't British fog. And I'm also very pleased to have Emmaus Ambassador Simon McDonald here today, so thank you for coming along. It's an emotional day for me because it was almost exactly 15 years ago that we launched Dyson in Germany, in this very room I think it was. So I'm delighted to be back here again launching some new technology. But I want to start off talking to you about really the heart of the new tap that we're launching, and the V-Blade, this one, which is the motor. So if I move, there we go. It's assembled in Singapore on a totally automated factory. It has no screws, no nuts, no bolts, no tight fits. It's all glued together, and with 37 glued joints. And the reason for that is that this motor goes over 100,000 RPM, and at that sort of speed, any out of balance just simply disintegrates the motor. So what we do is to jig the motor so that it's absolutely in line, put plasma treatment over the surfaces, and then glue the pieces together in the perfect position. It's a digital motor, which means it has neodymium magnets in the center. I could probably show that to you. Here we are. Neodymium magnets, which we make ourselves, we mold ourselves in a rather special technique to stop it flying apart. And then we put a carbon fibre sleeve over the top of the neodymium, a very, very thin carbon fibre sleeve. The reason for that is that although there's resin impregnated in the magnets, they would fly apart if it weren't for this very thin carbon fibre sleeve. And that runs in very, very close proximity, about 35 microns, to the electric field around the edge. Now, the reason we call it a digital motor is that the impulse to rotate the rotor, in other words, switching from the positive to the negative, is done digitally on a chip rather than mechanically. So that's why it's called a digital motor. And it reverses the polarity 6,000 times a second. So the motor has, in theory, infinite speed. Now, there are two other interesting things about it. We have no capacitors. Now, capacitors are rather large. And if I have, this is our previous digital motor, which has these huge capacitors on it. So we got rid of those, and the electronic board is now within the actual motor itself. Now, we got rid of them. What capacitors normally do is to smooth out the mains voltage. The mains voltage is rough, so you use capacitors to temporarily store the electrical charge so you can smooth it out and provide a smooth supply to the motor. What we've done is to use computational software to allow the motor to adjust to the rough mains voltage. So we've no need to try and smooth it. We actually adjust the motor to compensate for the rough mains voltage. The other thing we do is, previously on our motors, we've had an electronic eye which counts the rotation so you know how fast it's going by measuring it. We got rid of that, and again through computational software and algebraic formulae, the motor knows itself the speed it's going. So it's an intelligent motor, some artificial intelligence in it, going at very high speeds. It's extremely accurately made, and it has a compressor type fan, which is very suitable for forcing the air out of the narrow slots that we have here and on our, it's disappeared. Where's the V-Blade? There's the one somewhere around, through our V-Blade hand dryer. Because the slots themselves, one right over there actually, it's that thin one on the wall. And the slots are less than 0.5 millimetre wide, so you've got to force air through those at about 650 kilometres per hour. And it's that great speed that forms almost a physical blade that goes across your hands. The advantage of using a blade, like a windscreen wiper, windshield wiper, is that you're scraping the water off mechanically. Now, a hot air hand dryer tries to evaporate the water off your hands and turn it into steam, which is extremely expensive in terms of energy. It's 6 times the energy that we need. But it's also extremely slow. When I used them, I used to give up and wipe my hands on my jacket or my trousers. So the blade itself, the other advantage of the blade is that it goes between your fingers and across your fingernails. And if you dry your hands with a towel, you can't do that. I mean, no one sits there doing this with a towel and then going around all their fingernails. So it's much more hygienic even than paper towels. And of course it has 1/15 of the cost of paper towels, so very, very much cheaper. And of course a very much smaller carbon footprint than either paper towels or hot air hand dryers.